Let's learn about the Pythagorean theorem using Geometer Sketchpad. What is the Pythagorean theorem? It states that the area of the square on the hypotenuse of a right triangle is equal to the sum of the squares of the legs. You may already know this as a squared plus b squared equals c squared, but let's see what this really means. We'll go over here to some clean space, and I am using Geometer Sketchpad version 5. Go to the line segment tool and create a line segment, any length. Now we know that a square has 90-degree angles. We also know that a perpendicular line creates a 90-degree angle. So we're going to go to the arrow tool, reselect that segment, and the point at which we want the perpendicular line to go. Select Construct, Perpendicular Line, and there we have it. Now we're going to select the segment and each of the points, being sure not to select the perpendicular line, just the points and the segment. Now we're going to double click on this one, and it pulses. That's how we know we've done it correctly. We're going to transform and rotate it 90 degrees. Now we need a fourth side. So we are going to, like we did over here, we're going to select this segment, select this point, clicking once, construct perpendicular line. And there we have a square. But we don't just have a square, we've got a lot of extra lines. So let's take care of that and clean it up. This intersection needs a point. If we were to get rid of these perpendicular lines, we would be left with an L, or just a 90-degree open angle. So we are going to select the two lines at which they intersect, and we are going to construct an intersection. Now we have a point. We can clean this up by selecting the two perpendicular lines and display, hide. The point is there, but we know that will create a perfect 90-degree angle. So we select the line segment tool, connect the dots, and we have a square. Now we can select the arrow tool and click on each one of the vertices. Let's go to Construct Quadrilateral Interior, and it gives us color. If you don't like the color that shows up, you can reselect it, display, color, and choose a color that you prefer. We'll go with blue. There you go. Now we want to put this square in our toolbox. So every aspect of this square needs to be selected. Every segment, every vertex, and the interior. We've selected it all. Press and hold the Custom Tool feature and select Create New Tool. And let's call this our new square. You can call it whatever you want. And now it's there. We can test it by selecting Custom Tool. There's New Square, and yes, it works. So let's go on to the second part of this video. So now we're ready to prove the Pythagorean theorem, but we've got some building to do. Let's use our segment tool and create a line segment any length. And we want to create a perpendicular line. So we're going to reselect the segment and the point at which we want the perpendicular line to go. And there we have it. And we're going to use a new tool called the compass tool. And this tool creates a circle. So you place it at the center and you draw it out. And we're going to go to the very edge of that segment. And the reason we're doing this is because we know that the circle is a line whose points are all equidistant from the center, from a center point. So this is a useful measurement tool when we're making different geometrical shapes, because we know that no matter where we go, from the edge of the circle to the center, straight line, it's going to be equal. So there we have two sides to our square. We already know they're equal. And we're going to try something different now. We're going to select the original segment. And here, we need to put a point here where these meet. Okay, so let's go back, select the segment tool and this point, and we're going to construct a parallel line this time. And we have one more side to make of this square, and we can do it in one of three ways. You can choose whatever you prefer. In the earlier part of this video, you learned how to transform and rotate a line. So you could select this segment, double click on this point, and transform rotate. You can select a line and a point and either construct a perpendicular line or a parallel line. It's up to you. They all work. I think I'm going to go with perpendicular. So let's choose this and this line, and I'm going to construct a perpendicular line. And I also want to create a point. So I've selected the two lines that intersect, and I'm going to create the intersection. Now I've got all my points. And I've got way too many lines. So let me clean this up. I'm going to select all the extra lines, and I'm going to select display, hide lines. But my points are there, so I can go back to my segment tool and connect the dots. And you may be thinking, all right, I see a square and I see a circle. I don't see any triangle, which is what I thought this Pythagorean theorem was all about. Bear with me. We can now get rid of this circle as well, because we are finished with it. And I'm going to create some more space for to work. And I'm going to select this line. It's going to be our hypotenuse, and I'm going to name it. I don't want a lowercase c. I want an uppercase c, so we don't get it confused with the angles. And let me move it over here. Okay. Let's find the midpoint of C. We can do that by choosing the arrow tool, selecting the line, and constructing a midpoint. We know that's exactly the center. And we want that so we can create another circle, this being the center. And the reason we want to do this is because of a theorem that was discovered about 600 years BC. There was a philosopher and mathematician named Thales, and he discovered that if there are 3 points on a line, A, B, and C, on a circle, A, B, and C, where AC is the diameter. So let's create a point B so we can stay with it. Then the angle of ABC is a right angle. So let me see. Let me label B. And let's make that right angle that he was talking about. So we connect the dots here. Okay. Well, it looks like a right angle, but being mathematicians that we are, we want to be proven. We want it to be proven that it's a right angle. So let's see. Let us select the two sides and measure angle, and it is indeed 90 degrees. You may also be thinking, all right, well, what if it moves? Well, what if we move this thing around and it remains 90 degrees? That's pretty amazing. So we're going to leave it there, and now we can deselect or hide this circle. Oh, we want B back. And now we can add those squares that we made in the first part of the video. So select your custom tool and attach your squares on either side. And we are also going to measure the area inside here. We're going to color it by selecting the vertices, construct, quadrilateral interior. Okay. Now let's test this theory. Again, it says the area of the square on each of the legs, the sum of the squares, is equal to the area of the square on the hypotenuse. So let's see. We're going to select this square, measure the area, and it's 12.31 centimeters squared. I'm going to scoot this down here to be next to it. Let's measure this area. We select it, measure. I'm sorry, I did not click out of that. Okay, now we click on the area, measure, and it is 3.87 centimeters squared. Click out of it, select this area, measure, area, 16.18. Well, if you can calculate that off the top of your head and you know it to be equal, then great. Otherwise, let's check it with the calculator. So number, calculate, and all we have to do is click on there and add, click on the other area and select OK. And it does indeed come up to 16.18. So we have proven Pythagorean Theorem using Geometer Sketchpad. One last thing, we can select point B and display and animate to show that regardless of how they resize, their areas will equal C. The area of the square on the hypotenuse remains the same.